enough to go up. Let's kind of stick to this height. And then these guys go on here, like this, and like this, and this, this, and this guy goes here, and then this guy goes here. 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 And here. Like that. And then this guy can go on top of this, except it won't quite go on there, but that's okay. And this guy goes here, and this guy goes here. Chemistry is, as human beings on this planet, we try to understand the world around us. Chemistry, the truth be known, chemistry does not fall into a realm of understanding for us. So we have to use instruments, we have to reach into a world that we can never really understand, or reach into a world that we can never really see. And when it all comes down, we end up making guesses. It's like we make observations and then make stuff up related to the observations that we have made. So we say, how do we explain this? Okay, let's do this. Okay, how do we explain this? Okay, let's do this. Okay, how do we explain this? Let's do this. And this has been going on for 100 years. And the result of all of this is that we have come up with, scientists over the last 120 years have come up with a series of images and words to explain things. The images and the words have been very successful, but in the end, they're just fabrications of our human imaginations. And I want to put this right on the front page. Structural chemistry is a fantasy designed, built by human beings to explain observations. And I want to be real honest about this. I want you to go down this road with me, and I want you to look at this and say, this is a fantasy created by human beings. I guess I'm asking and pleading with you to go down this road and ask the questions, but then there's a point at which you just got to move forward. This is the road we're on. Walk down this road with me, please. One of the foundations of chemistry is carbon. Carbon is it's a complex molecule, but one of the predictable things it does is that it forms 4 equal bonds. And the 4 equal bonds stick out in equal, they stick out equal in all directions, and you can think of them as clouds that push against each other. They're negative clouds, they push against each other, and the result of all this is that they're all the same all the way around. It makes it a tetrahedron. Tetrahedron. So that's your first word. I think it's a cool word. Tetrahedron. It has 4 sides. Sometimes you see dice that are made with this. Instead of a 6-sided dice, you could have a 4-sided dice. Just 1, 2, 3, 4. Because the sides are all the same. And they put a common... The simplest organic molecule is a carbon, 4 equal sides, and then there's a hydrogen on the end of it. So it's a carbon, hydrogen, 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 like at the 4 points of the tetrahedron. And carbon with 4 hydrogens, it's a material that's called methane. Methane is, you could say, well, what's the big deal about methane? But the truth is that methane may be the most important compound in our industrial world. Methane is natural gas. It comes out of the ground. It's the very important characteristic of methane is that it burns. It burns. You know, I don't know how really much else to say about it. It burns and produces carbon dioxide and water. It burns. Another thing that carbon does is that it wants to form bonds with itself. So you can take a carbon and you can attach it to another carbon, and then it has, I need one more. Now it has, now it's like two tetrahedrons, okay? It's two tetrahedrons, and no, this isn't a tetrahedron. This is something else. How about this one? Put this one on here. This one on here. How's my time look? I think I better hurry. And if you look at this close, you see that it's pretty much the same as methane, but now there's two carbons hooked together, and there's 3 hydrogens on each one. Okay, ethane. What's the big deal about ethane? It's the same as methane. It burns, and natural gas has some of this in it. And then you can kind of like keep going down this same path, and keep putting more hydrogens on, and more hydrogens on, and more carbons on, and I need one of these with I have to kind of get my act together a little bit better. And if you have 3 of them, 3 of them is not, so what's the big deal about 3 of them? 3 of them is, guess what? It burns. So from methane to ethane to propane. Propane now. Propane, how is propane different? Well, it burns. There's not a whole lot of, it's not really a very big deal, but one thing that's important is that as the molecules get bigger, the boiling point goes down, and so, like, methane is a gas. Ethane is a gas. Propane's a gas too, but it's not a gas like methane is. And if you want to put a flammable gas in a tank, you got to use propane. You can't put ethane in a tank. You can't put methane in a tank unless you freeze it way down. So propane is the one you put in a tank because it's a gas, but it isn't as strong of a gas as the other two. Okay, let's do it. As a practice one, and the sound is going to have to go through the, but that's okay.